Okay, so let's move on the what we call the total harmonics distortion. So total harmonic distortion, or THD, is the term that referring to how many harmonics contained inside your output voltage or your output current waveform. So for a waveform that has a sinusoidal, so the THD is 0%. Okay, so if your voltage is a square wave, so meaning that you have the THD is very high, so meaning that you have a lot of harmonics, okay, inside this waveform. So usually the total harmonic distortion is always one of the main parameters to identify your power quality of your inverter, the quality of your inverter. So actually for inverter, for example, solar panel, so you have renewable energy here, PV connected. So PV will actually produce a DC, so you need to have an inverter here, and this inverter should be connected to the grid. Okay, so if you want to connect to a grid, okay, you need to make sure that the THD of the inverter produced here is less than 5%. Then you can connect your system, your PV, into the grid. If the THD is higher than 5%, you are not allowed to connect your PV system into our grid. So this is actually the standard. Okay. So how to calculate this THD? So it's actually very simple. So THD, so we have the THD voltage and also a THD current. Okay, so we go for the THD voltage first. So for the THD is actually by using this equation, which is the summation of all harmonics RMS, okay, square. So n can be start from n1 to n until infinity over V1 RMS. Okay, and then for current, same. THD for the current is same. So we need to actually have the summation of current RMS square over over I fundamental RMS. Okay, so mean that you can actually put like this. So this is V, because this is a cyclic AC, so you have only odd numbers harmonics. So V2 square, so V1 square, V3 RMS square, V5 RMS square, and so on, plus over your V1 RMS. Okay, so this is actually the equation to calculate the harmonics. The other equation that you can calculate the harmonic is actually by using exact equation. So exact equation is actually by using this, for example, the THD of the voltage. If you know, so this is the over V1 RMS over V1 RMS. So this is what I call exact equation. So this is only valid if you know what is the V out RMS, okay, for the waveform. Okay, I think that's all. Okay, that's all. So we will go for an example.